All right, welcome everybody. My name is Ben Martina, current president of the Robotics Society of Southern California. I am joined here with my officers and some members. Also welcome everybody online. Hey, Ross.
How you doing?
How you doing?
From the true north.
Yeah.
Still independent.
Yeah. All right. So today we have two talks. One will be by Alan and his continuing series in AI. We just started a new series that we're gonna try out. So in the past, we've gotten not complaints, but people giving feedback that our meetings are very advanced and they feel intimidated and they don't ever come back. So to fix that, we are starting a new series of beginner-friendly talks. Today I'll be starting it off with a very basic how to set up your environment and how to get started with some servos, LEDs, that kind of stuff. After that, we will break for lunch, and right after lunch will be our show and tell, which is kind of like the heart of the club, where everybody can bring in whatever they are working on, exhibit their project, whatever they're doing, ask questions from the experts, and have a lot of fun, just mingle. So the Robotics Society, we are a non-profit organization. Everything we do is free and open to the public. We don't charge for anything. However, we do accept donations in the form of memberships. That is $10 a year. If anybody is interested, it is entirely optional. You really don't get anything other than just saying you're a member of the Robotics Society. And you are able to vote for officers at the end of the year. But again, it is entirely optional. You can come to any meeting, every single event that we do, entirely free, and participate as much as you want at no charge at all. All we are here to do is share knowledge and get dirty and talk about robots. All right, so with that, Alan, you want to kick it off?
Yeah, for sure. All right. So good morning, everyone. Along with being more beginner friendly, I'd just like to point out that our show and tell and our open free access period after the show and tell is a great opportunity to ask questions of our more experienced club members, because whether we can make eye contact or not, we enjoy talking about robots and we're all here to help.
Oh, just one more thing. If you have a show and tell, let me know so I can add you to the list, whether online or in person.
Can I say one thing real quick?
Sure.
Yes. As usual, I brought what I call my handy box of robotic components, which is sort of a nod to the HBRC where I came from. Presenters, grab something free. I've got battery chargers, I've got servos, I've got all kinds of sensors in here. If you're doing a presentation, you get first pick. Then after you do a show and tell, you get to grab something from the grab bag.
Nice.
And then anybody who shows up in person after the end of the show and tell can come and grab one thing. And every time I come, I'll be bringing some freebies.
Nice.
Right on.
Thank you.
And in addition to the giving away of show and tell goodies, brought a huge ton of spare parts. I've got about 30 awards out there. They're all good. Got 100 555 timers. Nice bag. Oscilloscope. Let's say solid state. Oscilloscope. Yeah, a bunch of other goodies. Got torque, electric, screwdrivers. There's a multimeter. Let's go with these. Don't make me take them home.
Right on. Thank you.
So let's go.
Sure.
Yeah, I picked up one years ago, and I think I've used it all of 2 or 3 times. It's one of those amazing tools that I may or may not be smart enough to know how to use.
Well, you can learn.
I
Just get vintage computer project, then you have to use it.
All right, guys, let me go ahead and share my screen. So, this series can last as long as there's interest or until it's no longer, necessary anymore. So,
Replace.
until, yeah, something better comes along. So we all know the power of large language models and ChatGPT. You know, from the news cycles and all of the threats of AI dominance and, you know, no more jobs and, all of that stuff. So, there are different frameworks to get a large language model to be useful, because it's all well and good to chat with one and it keeping a memory of what you chatted about in that conversation. The framework that I'm working with is called Langgraph. It's an extension of LangChain, which has been out for about 2 years. Langgraph's been about for about 8. It's one of about, I would say, almost a dozen frameworks that attempt to simplify making large language models useful. You could consider them a mixture between a framework and a preferred design pattern. And so just to recap from last month. Oh, why does it? Yeah, I want the full screen.
It's only one light on. This is it.
There used to be a classic view. Maybe it's this one, maybe standard.
We need a dimmer.
Yeah,
Facility is
we're almost there. Okay, so this, all right, we're almost there. So it's standard. There we go. At least it's a little bit bigger. All right, so just to briefly recap, and this is all code that we went through last month, and what we're doing is we went through the introduction to Langgraph. So all of this code is available online. Let me go ahead and start pushing some of this into chat. There we go. And we went through the build a basic chatbot, and then we added in memory. So going back over to the code over here, we copied and pasted. We set up the language model, we set up memory, chatbot. We, using the graph, yeah, this is all based on graphs, so we added in our nodes and our edges for a start, the chatbot in the end. And so we'll restart and we'll run it all. And we have the chatbot from last month. So after all that work and hours of coding, we basically recreated a poor man's version of ChatGPT. Yay! But it works and it has memory. So we can do things like, you know, tell it things, remind me what is my name. And it remembers because we implemented that memory lesson, and we can ask it basic questions, and whatever was encoded in that language model, it will be able to answer. So things like, what is LangChain? It's not reaching out to the internet or anything. It is just responding to the information that it was trained on. Yeah.
Can I remember what you did yesterday?
Not in this version, but the framework is absolutely capable of that. Yeah, so we're going to get closer to that hopefully in future months.
Cool.
And then getting back to one of the earlier lessons is that the language model was trained by hoovering up the entire internet and then fine tuning it on tens of thousands of examples of being helpful. And then once the training is finished, which requires tens of thousands of very expensive GPUs that I'll never get my hands on, although I keep bugging my boss. Once it's trained, it's a fixed point in space and time. You can't train it on more information. It only knows what it knows. And so these frameworks like Langgraph allow us to extend the capabilities in interesting ways, right? But once it's trained, you use it. So there's a training cycle, and then you train it with tens of thousands and tens of millions of dollars electricity to train it. And then when you get it, whether you're running a local language model or bouncing the queries off of a cloud provider like ChatGPT, that's what's called inference, or using it, you know, asking it questions. You can't teach it anything more in training unless you have access to those, you know, millions and millions of dollars of infrastructure. And even then, it's not a great approach to train it on new information. So what you got is what you got, fixed point in time and space. And by implementing a little memory module in the framework, it can do things like remember what your name is for the session. But that's not to say that you couldn't bolt on some extra pieces of like a data store or a database that you could store and retrieve something to. So there's all kinds of features that we'll be exploring. Short answer is it can do that, but not my personal little one can't. The example can't do that yet. But and as fun as this is, and as smart as it is, it's limited for all those reasons and more.
Hey, Alan, is this running on your servers then? Is that why it was so fast?
This is actually being bounced off of OpenAI, the API, and I'm actually using O3 Mini.
Okay, okay.
I'm sorry, O1 Mini. O1 Mini.
Right. But you're using, right, it's like
Yeah.
a chain using,
Yeah, I'm just bouncing this off
your
of the cloud.
base is there, it's cloud.
Yeah, yeah.
Oh, but I was gonna say, also there is some level of fine tuning you can do for cheap, like for much cheaper, right, that we learned from the Vicuna days or the Olama.
Yes.
But that can't really add, that can fine tune the existing knowledge to sort of
Well-
make it, but it can't add new knowledge really that well, right?
Yeah. So let's kind of recap that. So Jim and I and another smart guy, we're working on fine tuning to create a poor man's ChatGPT back in the day when that was novel. And so when you're looking at making a language model smarter, there's generally two. There's the training portion where you hoover up the whole internet and it gets the gist of English. And that's the super expensive part. And then there's a second part, like a top layer that you could call fine tuning. And for those of us that were involved in the industry, there was a sea change between GPT-3 and ChatGPT. GPT-3 was fun, but it wasn't super useful. ChatGPT almost overnight became useful. And the trick to that was by fine tuning, it was a little bit of extra training with tens of thousands of examples of being helpful. That's literally what it was. You ask it a question, there's examples of it being asked a question and what the right answer looks like. And it got the gist of being helpful. That version of fine tuning, just to recap, was called reinforcement learning through human feedback, RLHF. Monumental and seismic in how it overnight made language models useful. About the same time, the first generation Llama models came out, and the next day they were leaked, so everyone had access to them. Whether they were then open source, and an enterprising group of people noticed that some ChatGPT conversations were so mind blowing that there was a website dedicated to posting those transcripts, like because this was when it was novel, like to get the right answer to a question. And so there was this website capturing the best of ChatGPT responses. It was kind of like someone's side project. And then some enterprising people figured out that they could hoover those tens of thousands of examples of ChatGPT being helpful, which then formed the fine-tuning data set to make Llama like ChatGPT. Sorry, hopefully that kind of made sense. And then Llama, that's right. The first generation Llama. Oh, Llama, yeah. And then the cat was out of the bag, and the website was taken down, but the damage was done, so to speak. But then everyone figured out how to do it. So when you're fine tuning, which doesn't take quite as many resources for smaller models, from experience, you really can't fine tune it on new information. Like, okay, well, if you can fine tune it, let's just hoover up all the internet from January 1st until now. But that's not really the way that adding knowledge, it doesn't work for adding in knowledge. What fine tuning does do is to give the language model the gist of how to do something. So if you want it to be helpful, you show it the gist of being helpful with 10,000 examples of being helpful. If you want to get a language model fine tuned for like helping a call support queue for IT or for healthcare, you could train it on 10 or 100,000 examples of the appropriate way to interact and respond to those types of inquiries. So it gets the gist of how to be helpful in that setting. Again, historically, it hasn't been working out well for new information, and there's all these other things that you can do to supplement the model for information versus knowledge. So we've got our chatbot from last month. It's working the way we remember it. I wired it up to radio this time with a nice little UI. And so if this is a backdrop, the main selling point of this month's talk was accessing the internet, and we're absolutely going to do that. But fundamental to that, and one of the many things these frameworks provide, is to bolt things onto the language model in a way that it can use it. So these things that we bolt on are called tools. So fundamental to giving the language model access to the internet is this concept of a tool. And all modern language models have a whole portion of their API dedicated to knowing what tools are available and how to use them. And so what I'd like to do walk you through today, and unfortunately there is going to be some Python code, but I'm not going to focus on it because the takeaway that I want to offer for this talk isn't what Python code to write to make this happen, but to understand what the framework offers to a language model, and then conceptually how tools work, and to hopefully get you excited about, because anyone can download all this stuff for free. If you have a fast enough graphics card, you can run a language model locally, or if you spend a few bucks for access to the OpenAI API, you can do this for free or almost free. And this is stuff that you could integrate into a robot, or you could integrate into a computer next to your robot. And these are literally the building blocks of agentic intelligence in this awkward adolescent period where we are writing Python code to close the gap between the language model's capabilities and its ability to understand and affect the outside world. So this is an adolescent period. This gives us a hint as to what the next direction looks like. But until the language models are able to take in new information on its own, these kind of building blocks, these Python building blocks, get you from a chatbot to something that can do real things in the real world, if that makes sense. So we're going to walk through what a tool is, and we're going to set up a couple of different tools. And then I'm going to show you how simple it is to add those tools to the language model in a way that it can make use of. And to kind of get the party started, let's start with a very simple tool. Now, this tool is a Python function. And so from a Python standpoint, a function or a method, you call it, it may or may not have input, and then it does a thing, and it may or may not return something, right? So let's set up a function for how many fingers am I holding up, right? It's just some Python code. And not to drain the slide, and we'll go through some of the decorations in a little bit. But so whenever you call how many fingers, it picks a random number between 1 and 5. And then it creates a string. He's holding up. Here, we'll do use. That's correct. A string that says you're holding up how many fingers, and then it returns the finger string, right? So going through this, and we'll just run it through a quick example here. So in the first time we run it, you're holding up 1 fingers. Okay, so grammar being what it is, we can correct that. I just don't want to. We'll run it again, holding up 4 fingers, holding up 5 fingers. So the point is that, and this is a simple example. They can be way, way, way more involved and complicated than this. So we have a function that every time you call it, it returns some random number between 1 and 5 inclusive. If you have less than 5 available or more than 5, we'll we'll just assume standard, a standard arrangement of fingers in a single hand, right? So that's all a tool is. Now, to make use of this, there's a little bit of decoration. We'll use a tool decorator, which is just a Python convention that adds a little bit of boilerplate code to make the tool, which is just a function, easier to access. And I had this whole thing set up where I was going to have two screens and I was going to be able to copy and paste code like real presenters do, but I couldn't get my Arch laptop to work. I use Arch, by the way. So we're going to do this the cheater way. So going back to a new version of the code for this, we've got a couple of different things here. So here is my copy and paste of, so we have the tool decorator. Here's our how many fingers function. Now, when you're setting up a tool, this is literally as simple as it needs to be. The tool decorator adds some boilerplate code that allows the Langgraph. It tells the Langgraph how to use it. And it actually gets its instructions for how and when to use the tool from this triple quote right here. So this is the prompt that explains to the agent, the large language model, how and when to use this code. And so this little string right here tells the agent when to call this tool. And it's a silly tool, but it's a good place to start. So we've got our tool, and there's a couple more tools that we'll go over in just a minute. And so we have a collection of tools. On how many fingers is the first one? We'll loop back around to the other two in a few minutes. Most importantly is the how many fingers tool. You look down here. We've also switched from a simple chatbot to a React agent. So I think you're on the wrong one, sorry. React agent was a revelation in 2019 or 2021. And it was a prompt and a set of tools. And the agent was allowed to call any number of tools in any order, any number of times in support of achieving the goal, right? So like if you had a SQL tool and then an internet tool, and you told it you wanted to iterate and update all the rows in this table to this one value, it would be smart enough because of the agent language model to be able to call the tool multiple times in the right way, right? Super, super cool. There's been a little bit of infighting because the modern React agent doesn't exactly work the same way as the React agent that was described in that 2019 paper. And the reason for that is simple. Agents and language models have increased in capabilities so far that you don't have to do things the old slow way anymore. So and I'll show you in a second, there's a very simple way of creating and adding tools to the agent. So you don't have to frame that on your own anymore and then interpret the output, and then it's all baked into the framework now. But it is still a React agent. It chooses to do, based on the tools available, the approach and the steps to get you from point A to point B.
That's a lot easier than that old way, is what you're saying. It was a lot more manual labor.
A lot more capable. Yeah, you don't have to write anything in the middle. You create your tools, you add your tools to a collection, and they can be a lot more complicated by this, but we're going to keep it simple. I want to get you excited, and I want to go home and code this immediately, because it really is as straightforward and amazing as I'm trying to make it look.
Quick question.
Yeah.
Go back to where, okay, it says use this for all questions about how many fingers are being held up. Is that appended or prepended to the prompt, and does that cost you in tokens?
Yeah, so there are.
Parse that.
Yeah. So the OpenAI API has an entire portion of the API for attaching tools. And so internally, behind the scenes, there is a portion of the system prompt that frames, including that text, about when to do what thing in the API. So there are tokens involved behind the scenes. But what's nice because is that between the OpenAI API and the fact that this model was fine-tuned on tool usage, it is far more straightforward than the old days where you have an intermediate prompt where it says, if you think this query relates to this tool, then output this output. And then you have another language, you know, you look for that output and then you call it and you spoon feed it back in. It all happens kind of automatically behind the scenes. Cool. Yeah. Oh, yeah.
And does it, I mean, it doesn't have to send this information for the tool every time you send a query, right? I mean, it's probably.
It probably does behind the scenes, but a lot of that is hidden.
Do they, but are you charged for that? In other words, in the math, yeah. If you have like 100 tools and you make a query, or you get charged for the 100 sentences every time?
Yeah, there is a caching concept where if it's a continuation of a previous conversation, those input tokens are generally billed out at a lower rate. But I'm honestly not 100% sure how the billing
Or
relates.
it's not like, doesn't remain in memory or something like, because it still has to be.
Because I keep seeing on the
they do have
APIs,
memory.
there's a cached versus non-cached input tokens rate.
Oh,
So perhaps, I'm sorry, I don't have the exact answer. It wouldn't surprise me if it was part of the token count for billing purposes. But the fun part is that this all happens for you, right? Like it's not like the old days where you have to write all the code that generates that prompt and then looks for the output, and if the output has certain characteristics, then you would know to write the Python code written to call a code and then feed that back in. That's all handled
like a bootstrap.
at the API on the API
You
side.
have to do your own bootstrapping.
Yeah, yeah, and so instead of worrying about all of that, you just worry about the tool declaration, getting your list of tools, and then passing that list of tools. And then, of course, there's Python code behind this, right? And when you're writing real code, you probably wouldn't use the out-of-the-box React Native function. But to get the party started, it's a great place to start. So we pass that list of tools in, and the rest of it is pretty much the same. So let's go ahead and do a run all. And there was a little bit of prompt engineering involved. It took me about 3 or 4 tries to get a prompt that told the language model that I wasn't asking literally how many fingers I was holding up in front of the terminal. I had to generalize a little bit because instead of going to the tool, it would be, you know, as a language model, I can't really see what you're doing. And it's not wrong. So I had to adjust the prompt in a way that gave it a few extra hints that I wasn't asking literally. And
Just out of
it's been pretty
curiosity,
reliable.
why didn't you pick something like pick a number of programs? Like, why do you want it to be specifically a visual related thing?
I thought it'd be a fun thing to. I thought it was a fun thing to try. Okay. Yeah, no particular reason. I just wanted something simple. All right, let me go ahead and add in.
Right, it could have been just pick a number each one.
The same thing, yeah,
Roll a dice. But you found out something interesting, that the model is smarter than you think, because it's asking, I can't see you. So
Yeah. It sounded fun to start it out, so I just kind of rolled with it. All right, let me go ahead and to switch laptops. Let me go ahead and add in some of the missing things.
That's an important aspect of the interface is that, you know, when does it actually get trigger your module is.
yeah, that's an important thing. So like, I'd be interested to know what you changed your prompt to, like, for that. Like, it's not literal, just call a function, darn it, if I ask.
Yeah, right. So it's my prompt started out with use this to answer any questions about how many fingers I'm holding up.
Oh,
And so the first couple seemed to fail pretty reliably. And then when I updated the prompt to be more general,
I see. It's just
there
this,
seemed to be
it's just this text you did multiple.
yeah, and it gets back to prompt engineering being setting up the language model in a way that it's able to understand. And it's an art and a science. In this case, it was more art.
Yes, art.
Yeah.
Right, you said that use this for all questions of fingers.
Yeah. So we'll go back down, we'll do our standard suite. Hi, is it working? My name is Alan. How can I help you today? I prefer that you refer to me by name in every response going forward. All right, all these things that would have been impossible 2 years ago. Okay, yeah, no problem. How many fingers am I holding up? And then if we look down into the logs, we can see that there's a tool call in here, and the tool call responds back with the right number of fingers. And then as a fun follow-up, how about something really big like, how about now? Now you're holding up 4 fingers, right? Okay, so you got memory, you got the smart LLM, and in the background, it's calling my fingers tool call to generate a random number of fingers. So like this is a really silly, like a stupid example of a tool, but it gives you a feel for how tool making works and how it can be applied.
Quick question.
Yeah.
I'm curious, just asking, how many lady fingers come in a box from a bakery? If it's gonna trigger that on just the word fingers.
Interesting,
How
right?
specific is it
Yeah,
when
how-
it's calling
Okay,
your
you
subject?
know, yeah, let's try it. So our getting back to our prompt, right?
He said all.
About how many
About
fingers are being held up. So
Well,
there's some
held up.
contextual clues about when the tool is supposed to be used. So let's give that a shot. It's a good idea. All right, can you say that again?
How many lady fingers come in a box from a bakery?
You're being generous with it there. With the
Yeah.
bakery part.
Oh. Oh, wow, okay.
24.
So it didn't trigger because you
It
were
did
very
not,
specific.
no.
Yeah, I like that.
Right.
Do you have a specific bakery? I recommend checking them out.
Yeah, but it, you should
Awesome.
have Portos. Yeah.
Right, so like these things would have been almost impossible to code for 2 years ago. And now with a couple lines of code and a function and using some boilerplate code from the framework, we have a performant agent that knows contextually when to call a tool and to use the output from that tool,
Wait, so
right?
are you saying it isn't connected or?
Not yet.
Oh,
Yeah, so right now it's just going off of its trained memory.
wow.
Yep.
That's pretty cool.
So, let's get to so with all that as a background and how cool.
Before you did say that you were contacting ChatGPT, did I get, so you're not connected right now, but you downloaded something before, or?
Oh, yeah, sorry, to disambiguate, so we're using the OpenAI, ChatGPT cloud, so we're running all the queries up to the cloud. But the chatbot that I've written doesn't have access to the internet yet. So any questions that you ask it, it'll answer them based on the language model that it was trained.
Okay.
Or in this case, it also has access to a tool for how many fingers I'm holding. Right, so I know it's
So
trying to
the
figure out.
LLM part is from the cloud though.
Yeah.
Just not the finger part. Yeah.
Yeah, the language
That's true.
model's in the cloud, but it doesn't have access to answer questions from the internet.
O1 mini.
Yeah.
Now, like
O1
when you go to the ChatGPT site and start typing, that one has access to the internet by default. usually.
Probably, yeah.
Yeah, but but if you're using it through an API, you can not have it connected. You're doing it from sort of
Yeah,
more manual, right?
Now that you mentioned, I'm honestly not sure. If O1 Mini has access to the internet when it's through the API, I'm not sure. But it's
Well,
not
it just said, I'm having trouble retrieving online.
Oh, okay.
Like if you could have.
Or maybe there's a flag in the API that you can set that gives it internet access. Okay.
So there's probably a way to switch that, but we
Yeah.
switched off
Yeah,
right
yeah.
now.
Yeah.
React agent is correct. Because you mentioned that I didn't follow the React agent role of this.
Yeah, so the React agent is a large language model that has a system prompt that gives it permission to call any number of tools in any order until it's able to solve the problem. So a very simple example would be like if you have a React agent and you give it the tools for a research paper, like you can do an internet search, you can pull the body, you can summarize. In a React agent, you can tell it to find the top 5 sources of information about Langgraph, grab the web pages from each, and then write me a 5-page summary, blah, blah, blah. And a React agent has the flexibility to do that. It understands what you're asking and can take multiple steps. Whereas in LangChain, which is still state of the art, is typically you have a series of steps that you need to do in order, and the language model will be one or more steps in that process. One of the main selling points of this new generation of agents is, and as scary and frightening and exhilarating as it is instead of writing the code step by step, you give the steps to the language model and the language model executes on them. So there's like, you're letting go of the reins, which as a lowercase d developer is really, really weird to do because I'm used to writing code and now I'm, and now we'll be right back. And now we're writing code and writing prompts to set up the agents to be able to execute those. So it's still the awkward adolescence. A year from now, 6 months from now, this may not even be necessary, but for now, this is the way to take it to the next level. But yeah, good question.
I just had one observation. It changed the like the your holding. It changed the capitalization, so there's some context there. So it would be interesting to try, like in your response, to cut the words out as much as you can and see if it fills it in. Yeah. But you don't have to do that. I mean, just,
yeah, and also notice,
like there's that trade-off, right, between how much of the string do you want to encode versus let this thing figure it out grammatically.
Yeah.
'Cause you
Oh,
could just have-
change the case.
yeah, your response could just be 4. And you know, what would it do with it? It would just say
Yeah.
4, or would it say you have 4 fingers?
yeah, it would be a fun thing to try. Maybe
Yeah.
during break, we'll adjust
Yeah.
the prompt. It'd be fun.
Oh, right. So then you can be
Or
more,
just-
you could generalize or be more specific.
Yeah, or say just 4 fingers, and say, would it say holding 4 fingers or not? You know, yeah, anyway.
Yep, and
Mm,
notice
yes,
finally,
okay.
it remembers from earlier in the conversation to include my name in every response. All these little things, right?
Yeah.
And this is code that we own. All right, so we've got a few minutes left. So let's take a look at
The internet.
what the internet thing might be. So there's a couple of Python libraries that might come in handy. I started with the Wikipedia library, but it ended up being not as much fun. So I had in my list of notes this Python library called Google Search. Now, this isn't something that you would use in a production environment. It's basically piggybacking off of your cookies and credentials and pulling up the search web page and retrieving information out of it. But for like personal use, so absolutely cool. You do a pip install on it, and you can do a Google search. You can say the number of results, what region, safe mode. If you want a list of properties like title, URL, and description, which I do, right? So that seems super useful. And in the interest of time, the second one that I like is called Beautiful Soup or Beautiful Soup Port. Funny name, but you pass it HTML, and it'll pull out pieces of it. So like if you want all the text that's in the body of a web page, you pass it the whole web page, you say pull out the body, and it'll do that. So it may not be pretty, but it works. So these 2 tools, hey, that's what we sorry, I didn't see you sneak in. These tools seem pretty useful. So let's carelessly add them into the agent to see what will happen. So an example of the Google search tool is right here. So if we wanted to do a search,
Where's your tool declaration?
oh yeah, sorry, this one's just the thing. Why are you upset? I don't know why you're upset.
Max tries succeeded.
We've got Google search on that. Let's do a run all again.
Google Boom. Detecting that you're.
SSL cert verification error. Well, that's disappointing. It worked at home. Why are you upset, buddy?
I feel you. I got that on the Wi-Fi when I installed it here. There is a certification, timeout expired.
All right, so
Oh, so you wouldn't let you search?
all right, so the last 5 minutes of this might be a little more hand wavy. But it's a very simple matter of wrapping that function into a tool definition. So let's take a look up here. So we've got the tool decorator. Our tool is called Internet Search. Our help text is use this to our URL for a specific internet topic. Interesting. English. Sorry about that. And so what this tool does, this is very simple, right? Just to demonstrate, is it'll do a search for whatever you're looking for. It'll limit it to one result, and I'll return the URL to that search result. You can also return the summary or the title or do all kinds of advanced stuff. But for now, that's our Google search tool. Our second tool is to use our beautiful suit. And what it does is you pass it a URL and it returns the contents of the web page. So now we have tools that will work well individually, but can also be used as combination. Unfortunately, I don't think my demo is going to work for an unknown reason. But if this were working here, you take my word for it, you would be able to ask it a directed question, something like, pull the URL for a web search on Langgraph, then retrieve the web page and summarize it for you. So, this is just me playing with it, and you just have to trust me that this worked last night at home. But with this instruction, it would use the web search on Langgraph and get the first search result, and pass that URL to the second tool to retrieve the web page, and then it would take the contents back, and it would give me a nice multi-paragraph summary. And I'm so sorry if my last few minutes are going to be hand wavy. Let's just try it and see what happens. Okay, so we're getting some kind of error. I have no idea why. I should have tried it on the thing this morning before I went. But when I did this last night at home, it would do exactly that. Or if you asked for a web page on Langgraph, it would actually give you a response with the Langgraph web page as an encoded HTML link you could click on to bring up the web page. And in the case of framing the question in a way that tells it how to use the tools in concert, it would actually do all that in the background. And so as we wrap up for this month, tools are really easy to add to a language model. I'll paste some more of the links to my supporting stuff in chat for anyone that wants to follow along. And with all of this as a backdrop, instead of just interacting with it conversationally, you could give it a full prompt, something like, hey, I need a research paper on Langgraph, pull the top 5 sources and all the information from the web page, and then give me a 3-page summary with an extract, and it'll execute on it. And so that's just from giving it tools, 1 or 2 of which connected to the internet. So imagine if you had a tool whose job was to turn on a light or turn off a light or set an alarm. A tool can be anything that you can write Python code for, which in this case, we had a silly, how many fingers am I holding up, and 2 internet ones, but these tools could very well also connect it to the real world, both as an information source, like getting your robot state, like getting your IMU values, as well as affecting change in the real world through Python code and a clever prompt that tells the language model how and when and why to call that tool.
Yeah, like go to the kitchen, orange, go to the chicken, go to the kitchen.
You could very well. So in
the kitchen.
Yeah, so Thomas has been doing a lot of exploratory work with language models and vision.
Yeah.
This framework would be able to connect that language model into an agent to execute on it, both as input and as output.
This is finally getting to the point where it's, if you wait long enough, the things get easier, basically. It was a year ago, a couple of years ago, trying to get your robot to do work based on through an LLM it was just like, oh, well, that's a whole project, you know, to hook these things up. Now it's getting so easy that I could just use my existing or your existing Python functions that like, I already have a function go to location. So then it's just a matter of now that could be a tool. And as long as the large language model can pull out the name of the room, it's like for going to any room, use this function.
Yeah, yeah.
And you could do it.
Yeah, there's this virtuous cycle of development and improvement as these tools become available. So this Langgraph kickstart walks you exactly through how to add features that we need in agents today with a couple lines of code, not exaggeration. So as these tools become more advanced, it informs the data and the fine tuning and the capabilities of future models to make these things easier. So this framework is based on a version of a model that wasn't available a year and a half, 2 years ago. So as this settles in, and this generational leap is hard for everyone, including people who have been working in AI for a while. But once we land here and get comfortable, it'll inform what the next step looks like, and then the next generation of models and support that ad infinitum. So I'll give another follow-up talk using some cool aspect. Maybe it'll be memory or RAG or GraphRag or something next month. But the TLDR, giving tools to an agent is easy, and that tool can do anything from internet to taking how many fingers you're holding up to controlling the real world. You just have to write the Python code and the prompt to explain to the agent how to use it.
One question about when you typed in that instruction to please go fetch the URL and then summarize it. At some point, you could be even more general in that request, and the system will figure out what tools to use. So if you just stated, go find out, the best recipes for, chocolate cake for me and tell me, and then it should go, oh, well, would it be able to figure out, okay, I have this way to search Google, and then I have a way to summarize, so I'll use it.
Yeah, so if we were doing a research agent, we would bake a lot of that prompt into the system prompt. So we could just ask it a question and then know what to do. But there's a level even beyond this, where let's say it takes about 10 tries to figure out how to successfully accomplish a task. What if there was some way that it could store off to one side what your goal was and the steps that worked, and then it could reference that as part of its fact finding for future operations. This is baked into the framework as well. So when we talk about agent capabilities, what I'm showing you right now is the simplest of toys. The framework and what it's capable of is so much more performant and capable than what we're just scratching the surface on now. So I'm thinking next month we'll talk about memory a little bit, because I want to do some work in that area. But yeah, this is like a kid in a candy store, man. This is fun. Yeah.
So you define a couple of tools. I wonder, also you have the GPT platform or whatever reasoning of that. If that information in the GPT and also in your tool, I wonder like how it overrides to pick that tool, because I mean, of course, in this one, we specified the URL was so obvious, right? Maybe GPT has that information already. I wonder how does it resolve to override to the tool versus use the whatever it's already in the trained.
Yeah, so in my experiments last night, and I'm so sorry I'm doing hand waving instead of showing you, there was a little bit of finesse to the prompt engineering to get the tool prompt to explain when to call the tool. And then on successful execution of the tool, I would actually go back and look at the web page myself and compare it to the summary. Like there's a CNN article that I was trying it on yesterday, and like the Langgraph, because I knew what page it was grabbing to kind of see. But yeah, so that's a very real challenge with language models now, is we expect them to be smart, but they're only smart up to a point, and they do still tend to hallucinate a little bit. So in my opinion, I don't want to leverage the language model as a source of truth so much as an engine of thought, if that makes sense. So I want to set up everything, the tools and the framework, in a way that it will call, if it comes to like the knowledge, I'm gonna call that guessing.
Yeah.
Right? So if we can set up the framework in such a way that has access to information and knows when to pull it, and that information source is trusted, then there's a very small window for hallucination. That to me resonates to me as being the way forward to the next step. But it's still so cool to have the language model tell me about black holes and ask it questions because it knows.
Yeah.
Yeah, no,
Even-
that's good knowledge. We
Yeah.
were all happy with that.
Yeah, even
Stop it.
in a 7 billion parameter model, you can engage it in dialogue about these deep concepts. And what is absolutely mind blowing to me is that a 7 billion parameter model appears to be the compressed sum total of all knowledge on the internet. 7 billion parameters. And if you're running it in 4-bit quantization, we'll call it 4 billion bytes. That is nuts. It's
Yeah.
lossy compression, but that's on a small model. A large model like this has more room to store stuff. So, anyway, so we're running along. I appreciate your guys' time. I'll post a couple more links in chat. This is accessible to anyone. So download it, play with it. Well, this isn't where we're going to end up next year. These tools will allow you to make an agent that can do things in the real world. And I want to get back into hardware mode, but this stuff is so much fun. I just can't stop playing with it. So thanks for your time.
Well, now there's we're gonna do a completely different thing. That was the advanced talk. Now we are gonna begin the first series in the beginner friendly talk, where I will be walking beginners in how to set up their environment and do some very simple things.
You want to give
Using Visual Studio Code and PlatformIO.
8 minutes. 8 minutes, right? Starting at the top of the hour.
That talk is
In
slow.
8 minutes.
Yeah, this is break time.
Yay, thank you.
We had a whole board meeting about getting a little break between the sessions.
Okay, so yeah, we have 8 minutes, or 7 minutes to just talk,
Stretch your legs.
stretch your legs.
Grab a cup of.
Yep,
Grab a donut.
some donuts.
So Alan, a quick summary of that is a few decades ago to make a function call with a single opcode on the metal. So we've replaced that single opcode with requiring a nuclear power plant to power a data center to make a subroutine call.
In a manner of speaking, yeah. Yeah, the higher level you go, the more instructions are needed. But the stuff that these language models are doing now, can't code as a person.
Yeah.
Like the generality of it. I mean, even the novel thing of like, hey, from now on, just use my name in the response, right? Like, I wouldn't know.
Yesterday,
Probably.
probably.
There's no version of Eliza that I could come up with.
Yeah, you asked me.
And also, guys, if you guys have a show and tells, let me know.
Yeah, I got a show.
Name.
Jordan.
Okay. All right, Jordan, you're second place.
Actually, was missing one.
Anybody else?
I have one for each one of these, and then I
Oh,
I have this one.
Oh,
Barrel jacket.
So
That's
great.
why.
Do you have any, do you have a need for any of the six?
Yeah, I'm like.
Oh, okay.
Actually, I finally like it sounds bad. So
It'll get me to shut up in my tracks.
Hey, Ben, employ those like the end,
Yeah,
like
usually-
you might at a
it was
time.
you, like,
Like if you take the time.
Then it got there. That was great.
You'd be like,
I
slide
wasn't
them over, and they'll be like,
It is.
it's over, I get it.
The first you're gonna be, all the light minutes.
Oh my
There was
gosh,
a brain
It was really.
interruption.
This is my kryptonite.
Oh, it's marzipan.
Yeah.
I pulled it off. I'm like.
Yeah, I like marzipan. Some people don't like.
Where did it go? I saw the, I know Alan loves it.
But
I love almonds.
I
that was
saw
version
some
one,
at the grocery
version
store
one
and I was like, oh,
version two,
Alan,
and then
I gotta
I
figure
never-
something.
That's a particular kind.
So
of,
I trimmed it down to
Peanut.
one bowl on top. so
Yes.
reduce that.
Yeah, they're basically crushed peanuts and sugar, right?
Yeah, probably.
Wait, marzipan, I thought marzipan was almond.
Oh, well, yeah, this isn't marzipan. Marzipan is a cookie.
Oh, it says,
Of these,
oh, no, that's like.
I put all four in just.
Oh, wait, I had this.
Yeah, I
I'm not.
want you to. Okay.
Wait, that's mazapin? Show me again?
Marzipan.
Mazapin.
Yeah, marzipan.
Oh, I said.
Marzipan, yeah, no, it's all right. Marzipan is the cooking thing, right?
Well,
This
it's
stems from
cookies, and it's
my
like
grocery,
Almond,
electronic.
cake that looks kind of like that.
We have a-
Brownish color.
We want to be selling kits. Like.
Oh, maybe
that
it comes from a similar root
I
as
had
a
this
word.
We're gonna have two or three.
Google search, you get the
other
AI
robots
result,
that-
and you're using
The
AI.
idea
to do
is
it.
you can start,
Yeah, I think.
or you can go separately,
And
and you can build off of it. One of the classes that we want to do.
I think so, I think
But
it,
you wouldn't want that, right?
yeah, it's funny, the Google search
100%.
Python uses
It's not gonna
beautiful
cost me
soup
50
to
bucks.
extract key features from Google
Have
search
attachment
results,
points
it's
where
literally
people can design their
slurping in the
own.
webpage. So again, not for
But
production
these are
use,
kind of-
but
these are
you know,
just
when
kind
you're
of
running it
concepts.
just,
Make
as
sure.
long as you're not doing 100,000 a second.
But you could just cheat and grab the AI summary.
Yeah, if you figure out the tag that it's held in, might as well. Yeah, extend beautiful soup and just grab that.
Oh,
I was just in my head.
And
straight
we're
because when you
working
do Google
on-
search, you get the AI result.
oh, yeah.
And you use AI to do.
Well, that's
the
like a snake eating its
So for
tail
robotics,
kind of problem.
smart fun.
Yeah, these problems are gonna be more prevalent too, right?
came
'Cause
together
AI
to
can
produce
tune
this
itself
kind of
and
3D printable-
Yeah,
stuff like
and
that.
about half the time, the AI generates a response.
And they
On point for it.
Yeah.
But it has the same problem that ChatGPT and other Microsoft Copilot. We finally enabled it at my work, so we can use it without running afoul of company policy.
Well,
But
more than
the,
on this, so
yeah, that's crazy. You guys, you're developers, like, you guys, well, you're not here, man. You know,
Well, mine, I have three, yeah, but I'm effectively responsible for
Yeah.
3 developments now.
It is stupid.
I don't know how to, but we have our own how to do that. We have,
not
Scout.
typical.
I
hate to use screws. It's more
I
of.
think there's a public version. We have a thing called iCode. I've been using it, and I started backtracking there.
Then I, sure.
They don't want it.
Private schools, probably, not used for free.
Samsung wants, I think, motivation for their own internal development, and so this way, those guys have to produce for the rest of the company. But, and maybe they're thinking about licensing, but they're gonna switch.
I hate using screws. Everywhere there's people that
Need attorney. How much would
Yeah,
that
so-
enterprise license be?
Yeah, it's embedded.
Big arm.
Jackson likes to extend.
And you can screw right in, and since they're metal, you can use Loctite in your house.
Yeah, mine are always.
Anyway, that's my, yeah, quick summary. Sam, and Sam's paranoid about anything leaking.
Even on my servos, just everything just snaps in.
You, that if you buy, if you license.
Yeah, I was thinking of doing a demo phase.
There are,
Yeah, it's easy to erase.
Yeah, and they literally identify you.
But the problem is it has like 20 million screen prints.
Yeah.
So you can't get sued for using, by the New York Times because, yeah.
Yeah, because it's got it.
But if you.
When it's
per-
done,
if you
now it's
use-
gotta
if
build
you have a
it.
personal account.
Okay.
your
Oh,
printer-
it's- it's got-
What about API?
Yeah, actually, I'm not sure. I can't speak authoritatively about both of them.
I didn't care, I've never done anything, but if I wanted to say, I
But if
wanna
you're
be.
working on company.
Well, not company, I'm talking about at home use. If I wanna keep home use.
If you use-
Then I can use their.
I've used these before. I've had no.
Is there?
Oh, okay.
I use Well, this is designed exactly those yellow motors.
Right.
Yeah, you can actually plug that in.
Simple theme, I was thinking, oh, I could just do one.
That's not.
servo.
How do you get
Yellow
on
motors
motors?
and the yellow.
But yeah,
Whatever it's called.
You can't get odometry out of that.
No, no, yeah, yeah.
Yeah, so you need something like that.
I was just thinking, this is.
There's a known set about
Yeah, I wanna say, you know, I like these. Oh, yeah.
Yeah, I know, I'm trying.
But I mean.
That's just
Yeah,
a button.
Yeah.
Oh, I have a tool.
That's like my doing it. Perfect.
In other words, but I did say.
Yeah, it's like, this is the easiest way. Somebody else try it out.
It won't be. Right, because, yeah, so
I don't know,
the
it's
tool
not-
tells it why and when.
Oh,
Yeah, it's still a-
You heard about.
I
wanna make you.
So it's
Yeah, and where, like, my sentiment lies, I don't want
about
to.
time. So it's like a timer and alarm.
Sources.
Okay.
Or if it has a repository.
Okay, but if you always want to, then you can build that into the tool and say, whenever anybody has to, you know, go.
It's still like the most intense. It does. Although everyone's kind of pushing for these. Got just for the body.
That's what I'm thinking is the smaller models will be just performance as not. Right, 'cause I wanna get
Hey,
to the-
Ben, can you hear me?
Okay, but we were also.
And I feel
like.
It is time. Let's get back to the meeting.
Logic analyzer, the timer.
All right, guys, we're gonna clear up the meeting. And get started with the first in the series of beginner talks. So in the past, we've always had, you know, our normal 2 lectures. They're always somewhat advanced, and some people might find them a little intimidating. And we were losing a lot of members a lot of people that would come in for whatever, from whatever background. A lot of new people, young people, high school students, college students that, you know, they're starting getting interested in robotics, and they would come to the meetings and they would be like, oh, I don't know what you guys are talking about. It's too advanced, and they would never come back. So we started thinking, okay, well, let's just do some beginner talks. So this is the first iteration of that. I will be walking people how to use VSCode instead of Arduino. So most people are familiar with Arduino, right? Arduino is everywhere. It has a giant, humongous fan base. It has the community is awesome. It's everywhere. You can get help for Arduino everywhere. And let me share my screen real quick. Okay, so this is the Arduino download page. If you ever played with Arduino, this is probably one of the first steps you go to download the IED. The IED it's great. You know, it was specifically designed for Arduinos, and it was made to be very simple. And because of that, you cannot grow it very fast. It has a lot of examples. I have the Arduino IDE open here. So it is very minimal. It's meant to get you started with very little effort. It has a ton of examples. Oh, this thing is on the way. Hold on. Okay, here we go. So it has a ton of examples. Again, it is meant to get you started if you are new to programming, if you're new to Arduino. It has everything you're gonna need right here on the menu. But one of the disadvantages of it, it is that it is a very, very lean editor. It doesn't have any way of letting you know when you have errors on there. It has very minimal highlighting. If you don't know any better, this is, great, right? But you are eventually gonna outgrow this. So because of that, we are going to introduce you to VSCode. Oh my goodness, the bar on top. Hold on. Okay. There we go. VSCode. VSCode is one of the most used, I would say, the standard for programming. It is a full-fledged IDE. It supports every language you can think of. Here at work, one of the things that I was surprised that I was able to do in VSCode was to set up an environment for STL programming. I mean, not STL programming, SLT programming. I don't know if you guys ever heard of that language. Before working here, I've never heard of it myself. I had to learn it, and I was amazed that I could set up the entire environment on VSCode. That's a little side track there, but it has support for every language. And one of the best things about it is that, let's get the bar out of here now. So this is what VS Code looks like. Once you install it from the website, it's probably going to be somewhat bare bones. It's not going to have whatever languages, but it has an extensive library of extensions that you can add to it. And the one specifically that we're going to be using is PlatformIO. So all you got to do is type on here PlatformIO. I already have it installed, but it's just a matter of clicking install, and it's very lightweight. In a few minutes, you are up and running. Once you are up and running, you can create through by clicking the little alien guy, it brings up the PlatformIO, and it brings up this little homepage. From here, you can click create new program. That's what I did here for. So if we were gonna say a simple Blink program, this is by the way, this is the way VS Code organizes your code. It literally kind of puts everything that's in a project into a directory, and your source code is going to be in the SRC folder. Here I have already a Blink LED program. So one of the advantages of Arduino is that you can just plug in your Arduino right onto it and it will work, right? And VS Code, along with PlatformIO, it does the same thing. It has the ability to connect to the Arduino in the same ways that the Arduino IDE does, just by plugging in your Arduino. And if somebody could be the camera person.
Oh, yeah, yeah.
You want to use my phone?
Just a moment. I got it. Hold up while we get everything arranged.
Sorry, we should have had this.
So if you do that. And then
I might need to stop
that,
stop sharing.
and we do.
Try that.
That. This.
Yep. All right, so I have an Arduino here. This is an Arduino Uno. I will show you how to set up a project in VS Code in a second. But it's a simple, just like any when you're working with your Arduino IDE, you just plug in your USB cord with your Arduino plugged in, and you are ready to go, right? Now I need to sort of switch over to my screen. Not sure. This is still gonna show up. Okay, yeah. All right. So when you create a project, it gives you this PlatformIO.ini. It's just a settings file. When you go on there, you can scan for whatever bunch of different things, including ports. Yes, it's scan. Hold on. It is. I'm blinking out. Well, you know what? In the home page, also, devices. So it's showing me. Let me see. I'm on six. The Arduino is on COM6. So now I can. What is the code? Scan. Monitor. There we go. So monitor, it gives you all of these different things, including the port. Then I just say port COM6, and I'm gonna save that. So now I'm looking at port 6, which is my Arduino. And if I get this part out of the way again, I can click the little play button, and it's gonna send the code to the Arduino. And just like the Arduino IDE goes through all of the compiling. And there we go. So now we got the little Arduino LED blinking. Let me stop the sharing so you guys can see the little blinky part LED there.
There we go. Blink, blink.
Blink, blink. So again, you can do the same thing from Arduino, except that in VS Code, you have the entire advanced IDE that has all kinds of nice, cool tools for you, including something that we were just like Ellen was going through, and an entire AI.
So what if you wanted to blink it twice as fast?
Oh, that's a great question. And like get rid of this guy. Okay. So let's say you're just a beginner, don't know how to blink it twice as fast. And I can tell you that it's just hearing these delays, but let's say you don't know that. If the VS Code has a little guy right here, which is the Copilot. Again, Copilot is built into VS Code, and now you can use it for free. So I can just go on here and I can say, how do I blink the LED twice as fast? And the AI responds with the delay, 50%, 500. So all we gotta do here is come here. And this is the thing that makes using VS Code so much better than the regular Arduino IDE. So now if I save this and I click the play button, it's gonna recompile and it's gonna reset my code to the Arduino. And when it's done, it's now blinking twice as fast because the AI told me to reduce the delay by half, which was 500. Before I was doing it once a second, now it's doing it every half second. So that is something that you don't have in the original IDE for Arduino. And if you don't like this part. The Arduino IDE, let's say you mistype something like this attach. There is no indication that, there's something wrong there. And you're gonna be scratching your head if you're new and not knowing what the error was, and because this is not gonna work. If you do the same thing in this environment, boom, it instantly tells you there's something wrong there. And it gives you a little, let's see what the quick fix will be. Oh no, it doesn't recognize what it is. But it does tell you that there's something wrong in your code. So now let's now that we know how to use it, how to scan for the right ports using the minimize this, the PlatformIO any. And here you can also include different libraries and that kind of stuff. So let's begin a project from scratch.
I have a question.
Yes.
So let's say you don't have some components at hand, or you want to test your program. Is there any way to connect like virtual environment where you have virtual Arduino and some buttons, like everything is
Like virtual button?
Yeah. So some kind of environment where you can connect that, test whether they work on the program on this virtual environment.
I want to say yes. This would be beyond this talk, and I would need to look up how to do it. But I'm pretty sure you could probably set up some kind of virtual environment and connect it to it.
They also have like an online Arduino simulator that I once did at a coding interview, and I don't remember the name of it, but you could just put like all the resistors and all the lights and stuff and put like very basic. It's still the Arduino IDE, but it's all browser based.
Oh.
And I could try to find the name of it.
And it can help, if you're scared not to build some components, for example.
I want to say yes. VS Code and PlatformIO are very extensive. They're very well documented. I would be surprised if it couldn't do it. Okay, so now let's begin a new project. So again, it usually has the home tab here on here. And we click home. To start a new project, you literally just click new project. Let's call it suite because we're gonna use a servo. The boards, it has a ton of boards. Oh, I want that one. So there's different manufacturers, different types of boards. Let me scroll down to the Arduinos. It has every possible Arduino that they make. And here's the Uno. This is the one I'm using right now. It automatically knows that the framework is Arduino. I'm gonna switch it from the regular to advanced. Yes, for projects. Okay. it goes through some initial setup because it has to set up its environment in that one folder, and here it is. So it starts you off with a basic program that is, again, it's just blinking an LED. But this is the other one. Hold on. Where is my new one? Sweet. Far quick in. It starts you off with a skeleton, just like any Arduino IDE. You got your setup where it runs once, and it's mainly used for setting up the variables, that kind of stuff that needs to load, and then you have your loop. In this case, it's just running a math function. But let's say that we were going to use this to sweep a servo. Again, I don't know how to do it, right? I'm new to programming. I've never programmed. So if I were to do it in Arduino, it does have the library of examples here where I could probably find a sweep program. Where's it at? Servo near the bottom. And servo's near the bottom. Or the bottom. Way down. Down. There you go. A little bit further. Two more. There it is. Sweep. And there's a sweep. So again, this would be the sweep, right? Here you can just use your Copilot and let's just say, how do I sweep a servo? And the AI gives me, I'm pretty sure it's the exact same code the Arduino gave me over here. Yeah, looks like. So here I could just copy this code here. It probably is. It has this is the Copilot from GitHub. It has the entire, access to all the GitHub projects and plus more.
It's free now. I didn't realize that.
It's limited in how many questions. I think it's like 2,000 queries that you get for free
Per month or?
per month. Yeah.
That's a fair amount. I was gonna cancel my, account, or cancel paying, but I don't know if I could.
One other question, well, can you do many different languages and they'll translate it into an Arduino code? Like if you wrote Python, would it make a program? It would?
Short answer is yes. In the tools generally, I'm trying to figure out how to frame it because you have a chat window and then they'll do inline code suggestions as well.
Yeah, in the chat window, then.
Short answer is yeah, in the chat window, you can paste it in and it would do a pretty good job.
The inline is very useful. I don't know if you've demoed the inline where you just say, change this line or change this function to do blah, and it edits it right in there. It's even better than cutting and pasting from the chat window.
So again, this is so much better than the regular Arduino IDE, and it, like I showed you guys, it literally just plug and plays with the Arduino. So this is the code. It's telling me that it doesn't know what the servo, because it is missing. That's it. The includes. I'm missing these guys over here. Now here it's telling me it doesn't know what this is. So originally when you first installed PlatformIO, it might not have all the libraries, but it does have the libraries in its homepage. So is on the left there. Here, look. And this part is getting in the way. But I mean, the first one here on top looks like the right one, servo. Okay, so let's just install that guy. Add to project. Please select the project. No, there's two swoops. This guy. So this is the same thing you will be doing in Arduino. So when you don't have a library in Arduino, it does have the library manage libraries where you can do the same thing. So now we go back here, sweep. Now we got rid of that error. The code is here. It is, I'm pretty sure, the exact same one that's in the Arduino. So now if we come here, click the upload button. Oh, I need to check if I had the right pin. It's usually 9, but let me see.
What do you
Yes.
mean pin? What does that mean?
So Arduino has a bunch of inputs and outputs. On this side, we got your powers and grounds, some digital and then some analogs. What the pin in the code here, servo attached 9, I'm telling the board that I am using pin 9, which is this little guy right here. They're usually labeled pin 9, and that is the signal. Your servo will always have these 3 wires. You have your ground, power, and the signal. The signal is the one that's attached to pin 9. And there you go.
You want to stop sharing so that it will full screen? Sure. Oh yeah.
So here's our servo.
Yay.
Sweeping back and forth.
You have Bender in the room. Yeah.
All right. Looking good.
All right, so what are the trade-offs? When you first beginning, Arduino IDE is a good start. It's gonna have a whole bunch of examples right there at your fingertips. So the learning curve is not as high, but eventually you're gonna outgrow it. The main gripes that I have is the syntax highlighting. It's terrible. It's very bare bones. I mean, it's just a text editor. In contrast with oh, I'm sharing screen again. In contrast with VSCode, the context highlighting, it's great. It's much easier on the eye. For any little thing that you type, it automatically brings up all kinds of stuff. Like say, if I were gonna do I don't know.
What do the colors mean?
Good question. So there are some words and colors that are reserved for the language itself. For example, integers and voids, ints, all this stuff. They are reserved words and their own color. functions, that kind of stuff, they're usually yellows. And again, the colors depend on what language you're using. You can get, different, color schemes. This is the default. For this, the structure is, using like purple, your variables and, functions, blues here. But again, the colors, you can get different, color schemes that whatever it's better for you. Some other languages use a little different color schemes. This is what it's using for the Arduino. If anything, you wanted to change anything, again, if you don't know how to do it, you have the Copilot, and it is very powerful. It's a full-on AI that will tell you exactly what is wrong with your code. For example, it knows where I'm looking. It knows that I'm working on this. So if I were to do that, and my code is broken now, let's see if Copilot can tell me what is wrong. So it did the code, but it probably fixed it. So it gave me the correct code by actually fixing my mistake. There's a ton of examples, a ton of use cases. We're using VSCode along with PlatformIO. It can be used with any Arduino board that you have, different chipsets, different boards. It works with a ton of stuff. The community is extensive. The documentation is great for any project that you're doing. There's, I'm sure, a community for it that has gone through the same stuff that you've gone through, and it's easy to find. And of course, you got the full-on Copilot AI there to help you. From here, just by knowing how to blink an LED, how to move a servo, you can do a lot of stuff with just those two things. One of the things that I brought to show you guys something very, very simple and somewhat cool is, let me like this guy. And I didn't have enough batteries for it, but I can just plug it into.
Oh, do you want to stop sharing?
No. Oh,
No.
yes. Okay. Because we're gonna do that just for example.
Yeah. Oh, I see it.
So here's the Iron Man helmet. It's missing the ears because I didn't want to screw them in, and gluing them in is a little tedious. This helmet is just using two servos, just like the ones we did right here. The combination of the two servos and a button can give you something like this. The button's over here on the side. Oh yeah. So that's it. Two simple servos and a switch. And there you have a functioning Iron Man mask. There you go. Nice. So originally it had LED lighting in the eyes and that kind of stuff, but it blinded my son when he put it on. This helmet was a project that he wanted to start with. He's 7 years old, and after we printed it, and he was so excited. It had LED lighting, but when he puts it in, even though the lighting is inside facing outward, it was still too bright for him, so we took it off. But I mean, just from what I just showed you, you can build something like this. Servos and LEDs are used extensively in robotics. So knowing just how to do these two simple things, you can do a lot. Anything from a rolling car to a little humanoid. I mean, the possibilities are endless of what you can do with just a servo and an LED. And then, of course, when you add more servos, LEDs, the things can get so much more cooler. Projects can range from anything from something like this to a biped, quadruped, whatever it is. All you need is an Arduino, a couple of servos, a few servos, some LEDs, and you're off to the races. So this was meant to be a very simple introductory into how to set up your environment, pluses, and comparing and contrasting between Arduino and PlatformIO using it in VSCode. As you can see, VSCode has so many better functions than the Arduino IDE. So if you're up for it, if you up for a little steeper learning curve, because VSCode using the PlatformIO, it has so many different features that the learning curve is a little bit steeper, but I think it's worth it at the end because it gives you so much more flexibility, so many better tools. But if you're comfortable using the bare bones, I mean, it's simple. You just plug in your Arduino. On this one, you also have to select what port you're on and that kind of stuff. So it's kind of the same in that regards. I guess the only good thing about it is it has the extensive examples right here in the file menu. But again, with the AI, that's all for free, and it's probably even better because they can extend on the examples depending on your project. The example might be good enough to get you started, but after that, it's really up to you to extend it. With PlatformIO, it is so much easier to extend your project to something more substantial with the help of the AI. Any questions?
I have one question.
Yes.
I brought my laptop because I wanted to install this and learn along with you. But it's Windows 7 and it said, sorry. Do I need 10 or 11?
Oh my goodness.
11.
Probably 10. It says 7 is no longer supported. I would say at least 10.
At my office.
Yeah.
Okay, so I can't run it on my laptop, but
You might be able to find the older version of VS Code that might run on it. Because I mean, VS Code has been around for a while.
but will the old version have support for the Arduinos?
It'll have support for the Arduinos, but I don't know if it has support for ChatGPT.
Platform, okay,
That's where you're really gonna benefit.
okay.
Can't you run it in the browser and maybe hook up Arduino somehow? Is it some plugin? I think VS Code in the browser.
I mean, you
And
probably
you can
could.
probably install something on your computer so it can talk from browser to Arduino.
I want to say yes.
Google that, try that.
Yeah, that's homework.
Yeah.
I mean, I'm sure it
There's
exists.
something called the Arduino Cloud Editor, allows you to write code and upload sketches to any official Arduino board directly from your web browser.
Yeah, so Arduino can do it.
Firefox, etc.
And VS Code runs in browser as well.
Oh, I didn't know that. I never tried it.
All right, so I mean, that was pretty much my talk. That was meant to just get you started with some very basic components that you can mix and match and create something much more substantial.
Where do these libraries downloaded? These are all C++ libraries, right?
It depends.
Because it's
Yeah, yeah.
a little container for itself, or?
It does. So when I uploaded this one, it literally puts it, where's it? Look on here. on the libraries, when you download a library, you download it directly to your project. Because when, like you
So
saw,
it's contained under that project, so it's just not much there.
yeah,
And it knows where to file the rest of it.
Yeah.
Just send it.
yeah,
PlatformIO has an expansive library of libraries for each framework and each platform. An encyclopedic. So more often than not, if you're looking for something, someone else has done the work of posting it to PlatformIO to make it immediately available through the PlatformIO interface. That
Yeah.
being said, you can still download libraries over the internet, and then you can put them in the library folder to take advantage of them, as well as to write your own. But yeah, it's
so I don't know if you saw that when I typed servo, there was like, I don't know how many,
314.
314 different libraries that you could use.
Basically different control algorithms.
Yeah, depending, if you have like a very specific servo library that you're using, it's probably there. For whatever, need that you have, it's there.
But if you have a bunch of projects, you use servo, then the library, like the Arduino ID, they're all put in one place. And if you
Yeah.
update that library, you're gonna affect all your projects at once, but, with the VSCode, it's gonna be per
Yes,
project. So
that's a very.
is there a
good point.
tool to update all of the projects that use it at the same time, or is it just?
So just change the config file, like in the beginning, if you needed to do that, and then it would auto pull it and auto like configure it.
From here, from the any file. Every project that you create, it comes with its own any file. From here, you can, include different libraries or, tell it where to look, that kind of stuff.
How do you get to that PlatformIO any file?
When you open up a project, it opens it up for you. And it's
But
also,
how did you get it to begin with?
I think it builds
It
it like
builds
as
it-
soon as you start it.
yeah, when you first create the project, it creates the,
Right, but how did you get PlatformIO in Visual Studio Code?
through the extension, button here.
Yeah.
So you look for, PlatformIO, and it's probably gonna be the first one. You click install.
Yeah, the web version's a little different. I'm trying to get it to work on my Windows 7,
Oh, okay. You're
but I don't know how to tell it I'm on an Arduino.
So you have to create a project, so,
No, we do that offline.
huh?
Yeah,
We'll do that offline.
Yeah, we'll go over that during break. Yeah.
Sure, that's what it's for. The show and tell,
Windows 7 machine.
we can work through all kinds of different stuff. So normally, I haven't been to the website, but this is what it looks like here. It has a home, button and a button to create a new project. When you click the new project, it's gonna tell you for a name and what board you're looking at, or what board you're using.
Can you search the boards there? If there's thousands, like if I have an ESP 8266.
It supports it.
Yeah, support it.
Yeah, I mean,
it's
it's
type ESP and it should jump.
That's, yeah, it'll-
I don't know if that's search.
there's a lot of
that
ESP
great,
boards.
but
Yeah.
You may have to type the whole thing. I'm not
And
sure.
Pico and Tiny.
it's alphabetized, so depending on.
You can start typing them, but you have to be quick, one of those, you're typing in a menu, so. I don't think there's an actual search.
Why does
It doesn't have search.
account, like PIO account for the?
They should put LLM on the top of this.
Yeah,
Right?
Yeah,
like a
account.
function.
No arguments here.
18 megas,
I never.
Oh, yeah, I just quick search. You type in ESP32 and then they all.
Or does
There's
it,
all
like,
your ESP.
Yeah,
does it search the whole string for your?
Yeah.
as you
Yeah,
type?
because you type ESP.
You don't have to type, you don't have to type in the beginning, it works.
Yeah.
partial search.
Yeah, so the window's a little bit small. You'd probably see the search bar on top if it was. in the-
Oh. I didn't.
Go scroll up.
Yeah, it's okay. You got it. It's formatted.
Oh, there is like a.
On the
Yeah,
right,
he's cut off.
on the right scroll bar, scroll up and maybe we'll see the search on the top of the other one.
No, that's already, actually, I can't even see it.
I feel like the search appears inside of like the board like
Or
window.
To the far
but
right,
things
next
like-
to the video, there's a scroll.
Oh, this guy.
Yeah.
Let's see.
Oh, no.
No,
No, it'll.
Oh, there it is.
Like it appears inside the board text.
There it is. Yeah, it's just, it's embiggened so you can see it easier on screen.
yeah.
Oh, all right, but yeah, it's there.
Definitely use that, but never had a problem, never had for a while.
But yeah, the library is extensive of what, of hardware that you can connect to it. Some of the stuff you're I've never even heard of.
Is basic stamp still there?
Oh, God.
It might be.
Basic stamp even take Arduino code?
God, that takes me back.
And I just found out the web version will not run or debug. It says you need a run environment, which means you have to install VS Code desktop. The web version of VS Code is only an editor.
Oh, it's for editing.
Oh, okay.
So
Good to know.
I got blocked.
Oh, didn't it say, oh, but the Arduino one said it lets you download code. The other link I sent, the Arduino cloud editor, I thought it said, lets you download code.
That might be
Play with this
different.
later.
That's the
It
Arduino.
says write code, upload sketches to any official Arduino board from your web browser.
Are you
The
looking at the
Arduino
Arduino?
one.
Or the?
The Arduino cloud editor.
Yeah, that's a different thing.
So that one's full,
That's
but,
not VS Code.
No.
right, but if you can't use VS Code, you have to
Yeah.
upgrade your OS.
Well, I'm using the Arduino IDE, which works.
Right.
I mean, yeah, I mean, if the Arduino IDE works, it's a out of the box kind of thing.
Or
Plug
you
and play.
You could use, you could use VMware Workstation to install Windows 11 and then install VS Code on top of that.
There you go.
It won't because of the hardware doesn't support the security features in the chip.
What is it, Windows 7 you said? Oh, yeah.
Intentional. Okay.
Oh, you don't want, oh, you don't like that new
More stuff that only runs on stuff.
You could also try like NeoVim.
newer stuff.
You could also try like NeoVim, which is like a terminal editor, which takes plugins, which I haven't looked into it, but you might be able to get PlatformIO in that, or like use PlatformIO like as like a terminal application. Or that might be way worse than just upgrading.
You have another laptop
I
that's
do.
newer, right? Or will soon.
So, I mean, it's very simple. Once you get VS Code on there, you search for in the extension library here, PlatformIO,
PlatformIO.
and it just, click install. It takes probably less than a minute for it to install. It's very lightweight. And once it's installed, you got the little alien here,
Yeah. I
and
don't know
from
where
there,
they came up with that.
you're up and running.
If you want to change processors, you can go with like the particle processors, and the editor is web-based and uses over-the-air updates, so actually, yeah.
Oh, over the air? Oh,
Yeah,
through-
I mean, you can do it with the Arduino ID too. Yeah, it does, it's all over-the-air updates to all your devices here.
That's, oh, that's a lot better than the plug-in like before.
All right.
And you can set up Arduinos for that, that's like an ESP set up for that.
So any other questions? If not, I guess we can break for lunch now.
But yeah, on the computers was always. Yeah, you're good. Hi, so, I am, I don't need to join audio. I'm gonna talk about the robot I've been working with, that I just prepared, and it's a sort of a beginner, robot, that, uses, the microbit card. This is the robot here. It's called Maqueen, Maqueen Plus. Ben and I used to in the past, we've done demos with the, here's the, I guess, oops.
Yeah, so the Maqueen is
We
based
did
on.
demos with the earlier version of this that shows, that drove around and, I have that traffic thing that we had three of them and doing traffic. Go ahead, Ben.
I was just gonna say that the Maqueen is based on the small little British, developed little board
Yeah, it's called the micro.
called the microbit.
This is it here.
England, they were trying to, get their kids into robotics and kind of technology, so they, literally the country sponsored the creation of this board, which is very, very simple. It has everything, built into it, from a little LED screen, if you can call it that, that it can display, a bunch of different, shapes and that kind of stuff. But, the beauty of it is the bottom of it, those are kind of like its pinouts. See there you go at the bottom.
Yeah,
And that, you can, it's kind of like its pinout. You plug that into, what they developed as the Maqueen, robot, and it's just a little tiny two-wheeled, robot base that plugs into. The one, Jim has right now, that is the new version that has a scooper at the front and, all kinds of other goodies.
yeah, this is an add-on. You buy this separately, this scooper, or they call it the loader. And there's other ones you can buy for it, and then it comes with this servo here to control the loader. And then you notice, the micro bit is used in many applications besides robots. This plugs into like a game controller, plugs into anything that they've come up with. You have that on? So this one is a kit that, and I guess I should get, let's see, hold on. I should make sure this is what it looks like. And this is sort of the LEDs that light up. This itself is you can do lots of projects with. It has buttons, LED, GPIO, 3-volt power, microphone. That's new. So it's got a lot of stuff going on. It's got a processor, a compass, accelerometer as well. It's got Bluetooth, low energy antenna. So you can communicate between them with radio through this. So it's a very well featured device. There's a new one that has a microphone and a speaker too. So it's got a lot of stuff, all in one device. Compass, accelerometer, again, all these beautiful multicolor LEDs, and then other colored yellow colored LEDs. So that's it is a very capable thing. And then you buy that, and then you buy the robot is sort of a separate purchase, which is this, the actual Maqueen. And then this is what I have, the older one. The newer one, this is mine that I just showed you, which is a little different. It's the version 1. Version 2 is out now. But these are very well documented with lots of instructional lessons that you can go through, and it takes 5 minutes to set it up, really, to hardware wise, or a little longer maybe, but it's a few screws, a little extra for putting in the loader. But there's all these varieties you can buy. They call it the mechanic. So you can you buy add-ons. And this was more like the one we had, the Maqueen Light.
That was the original.
Yeah, I don't think they called it Light when I got it, but
It was just a Maqueen.
Maqueen, right? They renamed it to be those. But yeah, and then there's a lot going on here. A lot of stuff that you can grow into as a young developer to just play with the robot. And it's an ARM processor. It's it's pretty fast. quite reasonable, and it can run on AAA batteries, the new one. The Maqueen plus V2 can also run on regular batteries as well. Yeah, you can do, this is what mine looks like. And so that's sort of the basic hardware. Here's the AAA battery version versus the lithium battery. So one of the beauties of this, and there's all sorts of documentation on it. Here's like the the introduction. Now it's going to go through a quick demo of what it can do. It also, this one, and I think the new one, it comes with a little track here where you can put this down. This just comes with it, so you can do line following right out of the box. Got 2 line following. I like this one better than I got both of these working. Yeah, and I'll show you this one if this thing gets flat enough. It's paper that's been wrinkled like that. So this is the hardware. Now on the software side is where things get really interesting. What it does is it uses MakeCode from Microsoft, and it's a fairly simple system. It's a very let's call it very user-friendly system, where you can get an account and keep track of your projects, and then you can click on a project like this one. And now there's also, I just showed you all those in these books and these booklets. They have all these different projects that are already written, so you can follow the link and download it, and you'll see there's links in for each of these each of these lessons. Like here's the circular one, right? And then I'm going to show you this one, and this is what the robot is going to try to do. Is you start it on this line, and it's going to go down line, and it tries to go around the end, and then sort of go counterclockwise around the whole structure. And like if you click this, turns out this link gives you an older version than is currently available. The code is slightly wrong, but it's easy to fix by just changing the one word. It was like plus with 2 S's, and so to start, like I'll just show you quickly, to start a new project, you can just type a name in here, sample, and this MakeCode is really, it has multiple modes of operation. The first is blocking, where it's quite easy for beginning users to use. Drag and drop, and these are your familiar sort of things, like what to do at the beginning when you start it up, and then what to do repeatedly. So like you can put what you want to do over and over again in this forever block. And what's nice is as you advance, you would want to go to a written programming language like JavaScript, and it'll translate back and forth between those two. So you can see exactly what you did in blocky in written code. So this just shows you show number 0. If I can change this to a 5, and then it says show number 5, and then it's gonna do this LED plot. And then furthermore, there's a simulator built in. So you can see this is already displaying 5 here. And whatever you put in here whatever is possible will simulate on this. This doesn't show a robot, but This is just the microbit itself, but anything you do over here, including pressing these buttons, it will emulate it there. And also there is Python too. Python, so if you prefer Python, you can do that. The Python runtime, when I used to use it, or when I used it in the past, it ate up more memory. But it's up to you. If your program is small, it probably doesn't matter. I'm preferring Java. I discovered back in the day that the JavaScript or TypeScript was the fastest and least memory being used. So this is one this is the program they gave me from following that link. I just had to paste into a new project. The other thing I had to do, I'll go back to this sample, to use you notice there's nothing about the Maqueen here. So all of these are the different commands, the different things you can do, play music. This is all part of the make code for microbit. But if you want to use a third-party thing like a robot that you purchase, then you go to this extensions, and there's all these different extensions for servos. It's sort of like a library for Microsoft code, right? So here you can say type in Maqueen, and it'll show you the different Maqueen extensions. Maqueen, this is the one I think. This is the one we had been the original Maqueen. Then there's, but then I wanted Maqueen Plus, so I put in Plus. I put in Plus here. So DFRobot, there's two of these. Mine, you can see this is the picture of mine, and the new one here with that takes it's a little different structure, and takes the AAA batteries. And so I use this one because that's the one I have. And now you'll notice a new item appears, and that has all the different functions that are available in this robot. And this whole thing is to program this board, but when you add this extension, it now knows about the robot commands. So this knows how to move the motors, how to use every feature that's on there, including the line tracking sensor and the RGB color lights, which are only on the robot, not on the Maqueen. On the Maqueen, but not on the original, just on the board. So you go to this line following, and then I'll plug in so to program it, you plug into the board itself, but to charge this robot has the battery. So I plugged into the is there some questions? Can't find the stop button. So yeah, you plug into the board itself to program it, and then you'll see, in Windows, you get a microbit, you get a new drive that pops up, but you don't have to work with that. You can. There's multiple ways to download code. You can download directly to the robot. So, or you can download a file, and then you drag the file into that folder, and then the robot will reboot and flash itself. But if this is working, this is kind of the easiest way. So you write code here, or again in blocks. This is what it looks like in block code, which again I copied this from their example, the first lesson or the second lesson. And you can see it's doing things like read the line tracking sensor, and if the value is between certain things, then move forward here. And if it's other values, then turn right, or turn left, and that sort of thing. So that's kind of I won't go into the detail, but that's sort of how this works. And then you can quickly see if you're more of a like writing the language, then you can, or you want to learn, you can see what it translated to over here in the code. And then so you hit download and you plug in, like they just follow very easy instructions to follow. Then it will pair it, and then if it's connected properly, you'll see it come up here in this window. And then hopefully, okay, so it got connected, now download, and you'll see this downloading, and that's it. Now the code is on board, and it's immediately running. What's interesting is if you have if the program starts moving motors immediately, if you're plugged in, it will not move. That's definitely a good feature. So, but as soon as, so then, now the robot has an on-off switch. And when you unplug, it's in the, I leave it in the off position. So, now let's, now let's put this down on the ground. Maybe I can get my,
Maybe stop sharing.
I can share with my phone.
Jim, how about the table right there in the middle?
No, it's not big enough here.
We can join two tables.
Well, I can, actually, the laptop has a camera, right?
Sure, yeah, I got you.
Oh, you want to do it?
Yeah. Give you the flexibility to show what you want, when you
Well,
want.
it's just, yeah, thank you. Sometimes a cameraman is really valuable.
Thanks.
Alan.
And sometimes Alan is very valuable.
Sometimes.
Okay, so I turn it on and,
And then on the black floor.
Black floor.
yeah, so this is, I haven't edited this at all. It's just like the basic program, but it'll go back to there and then, oh, something.
It seems to be nudging its way.
Yeah, it's trying to find tries to find that block thing, and then as soon as it does, it'll move forward, or, yeah, this. Oh, stop it. Getting a little, okay, come on. Yeah, it's getting a little stuck there.
Ah, huzzah.
Now it's going, yeah, it's doing what it's supposed to do.
Okay.
Oh, this is the weakest part of the code, I guess, is where yeah, now it's working again. I mean, this is literally like, you saw how many lines of code that is, and it's going around, we never had this type of challenge when I was doing the line following a few years ago, but this is an interesting thing to just, yeah, it gets stuck on this one. I wonder if it's, yeah, it's not flat enough, I guess. It's only that one that, all right, here we go. So like, well, now we've showed this one, I can flip this over and reflash it and show you the other one.
Okay.
I think it's working. Then I'll finish because.
Damn, oh, no. Shoot.
Yeah, see there now. Oh, stuck. But now it's working.
Ah,
Cool.
huzzah.
Yeah. So yeah, that's that one. And that was just an example right out of there. So, yeah, you flip this over. Well, this one's not quite as interesting. I mean, it's.
Kind of what it was doing already.
Yeah,
Yeah.
it'll probably work with this.
Well, I don't want to take, you want to see that one? Yeah, well, I don't want to take.
You got the
too much
old
time.
shoulder cam. There you go.
So, oh, thank you. All right.
Going in circles on purpose this time.
Should still be able to
Now
get the
what we
circle,
do
I
is,
think, even with the same program.
Oh, you can see if it works for the.
Yeah, I think it would, because it's still looking for the edge.
Well, I'll load up, I won't reprogram it yet then, but this was line fall number 1. So this is, this code, or this example was for the circle. But yeah, let's see, as a quick test.
It depends how many sensors there are.
There you go. There you go. So it's like using the left side and turning whenever it doesn't see the white.
How did you know? Well, I guess it's doing sort of the same
Yeah.
thing.
Build a couple of these.
Well, you didn't even look at the code, but. Well, in fact, this is a simplified case of the other one. Yeah. Of the other side. But just to, in fact, I think this works better than the code that was written for this. I'll show you. I had to slow it down. The code written for this, for the circle was as simple bang bang, as Ben likes to call it, I think, you know. Basically, if you've gone over the line, go the other way towards it. But just to show you, I guess, you can do the screen or something if you want. But basically, I'm just hitting the download. Oh, the other thing I wanted to mention is if you have a mistake in this code, immediately you'll see a little red one. So I just like, I can share again, or it won't show me that. Or yeah, it would, or you spotlight it.
So yeah, as soon as you share something, it'll pick me up the screen.
So if you go back here, if I have a mistake, then there's this little red thing and it tells you, you know, well, it's actually got it. Yeah, it'll show you an error and it's a pop-up error. This would have been great when I was first programming back in college and using an old compiler, you know, or using it for beginning programmers. That, you know, it's very nice that it does this for you. Instant editing or instant feedback as to whether there's an error. And if you're using the block stuff, you can't make that kind of error. You could do something that won't work, but you won't have syntax errors unless you, well, if you leave, I guess if you don't.
Yeah, the shape's prohibited.
Everything you drag in will, you know, not cause a syntax error, I don't think, because, but, so now I'll just hit the download button again, and it's already paired, so the next time you iterate your code, you saw, it's very fast. So let me stop again, and then we'll unplug. And, we'll go here, and I'll show you, I think this one is not as good. I slowed it down, so maybe it's okay now, but it is faster than the other one. When I first booted this up, they had it at 70 speed, whatever that means, and it was at my house. It was going off, so I put that in half, I think, or even lower, 30, and now it's fine.
I kind of want to do 70 there.
What's that?
I kind of want to do 70 there.
Oh, it only makes left-hand turn?
Oh, maybe that's the issue that I was noticing. It was not, yeah, it was doing this kind of behavior where we would go off and then come back, because it's even if it loses the line, it keeps curving. It keeps its turn.
Reading the edge of the paper of like when he's flashing. I'm curious to see if it can trace the edge of the paper because of the darkness of the color.
Oh, that's what you were saying. No.
Just, that might have been one.
Actually, that's another great thing about this is you can see these blue lights indicate what the robot's seeing. So if it's if the blue light comes on, it's seeing black, and you can see there's several blue lights. So here you can. This is the calibration area. It actually even has a calibration button. So if your lighting is, remember we had all those lighting issues? So
yeah,
if you want to calibrate, you hit the calibration button when it's in the calibration area. So you can see how you're getting visual feedback of all the sensors, the infrared sensors. So
programmatically sets the thresholding values for the light sensor.
Yeah, probably, yeah, and they said it's automatic, so if you press this, this has a speaker too, but yeah, there's a button, it's called the count key, so calibration.
Got it, okay.
So that, yeah, it probably sets the threshold based on the lighting. You put it over there and you say, this is black, this is what black looks like.
Pretty cool.
All right, well, thank you, and yeah, and so that's. Yeah, cool.
Yeah.
Yeah, so we can see that.
So,
So,
a little small, a little small.
okay.
Yep.
I guess, I forgot how to zoom in and like make things bigger. I thought it was like shift plus or control plus. Yeah, fair enough. Yeah. That's good.
Same thing works on VSCode, believe it or not. Electron apps.
So what this is that it's kind of just like a in progress demo of a joint streamer where over UDP it streams like an array of joints that goes to the other one. But this is this is gonna get rid of like also sending like the labels for where it's supposed to go in there and kind of just like streamline the whole process. Because both sides of the server and the client are being synced with URDF, where it takes the URDF like robot XML file, turns it into a graph, sends the nodes over, populates both graphs or the graph that like the server. Yeah, the server sends the graph back to the client, and basically like it's just kind of like a very lightweight like joint streamer without ROS. So the way that this would work is that we would first we run the server. We run the server, and now it's listening for any connection to come in. And once it gets a connection, it's then going to save that IP address and the source that it came from, track that, and send it basically stream all the joints back. So now we're gonna run the client graph thing that I did not name very well. And so this is the first initial connection coming in, and it saves the IP and the port. And then basically it figures out based on like the bytes being sent in, like, okay, I could send it to this link, and this link. And then for the actual syncing part, like here's just a basic XML thing. But this in theory should work with like a URDF file. Just because like I'm pulling the same types of names. So then the part where this project's kind of going to is like a motion capture type of thing or project where I might need some volunteers to put that over there. So if anyone wants to stand in the middle. Yeah, good enough. We're gonna run this pose capture program.
All right, who wants to post?
I mean, just someone stand in the, I'll stand in the middle. Okay. So yeah, now it's running. It's a little slow just because like this is fully CPU bound. But what it's kind of doing is that it's recording the depth, tracking like where the person is, but also like putting the actual like point on the depth. And if I move closer, you can see that like the circles get bigger because that's like a direct like correlation or whatever to the Z coordinate. And I think 1 second, there should be like You should also be able to see the skeleton on this, which might not be like popping up because it's hidden. Or maybe it just needs like someone's full body.
You put your arms out, maybe.
This was working like a few seconds ago. But basically, I guess it's hiding where the skeleton should be. That's the other thing. This can also do multiple people detectors, making it multiply slower at the same time because this isn't like threaded, because I didn't optimize this at all. But the idea is that it's using like a normal like image like AI like detector, which I'm using media pipe. I might change that in the future. Isolating everything out with YOLO, and then it takes like the coordinates that I tracked from like the normal RGB space, and then it maps that onto the depth space. So now you could get like pretty much like absolute value like depth tracking from this.
Stereo camera, which one is that?
It's the Intel like D435.
It's a RealSense.
Yeah, the RealSense one. So like it's a depth. It records both RGB and depth coordinates.
It's sort of it's like the Luxonis Oakey series.
Yeah, it's exactly like that, and
Used in disparity depth.
yeah, like it casts out its little like points, looks at the
Left and right,
distance.
It has to match from left to right. It has to match the pattern to determine the depth.
I think the RealSense is the IR grid. I think.
Yeah, no, it's like the Xbox Kinect sensor where it casts out a big graph.
I'm sorry, that one is.
So yeah, it's not the stereo one.
Structured light.
Yeah.
So that can have issues when there's some light emitting from something too, probably, like
Yeah.
screen.
But I think I might be able to see in the dark. I'm not really sure. But
It's an easy way to find out.
Yeah.
Well, I mean, we had a projector on, but.
oh, actually,
Turn it back off and point it this way and see if it picks up all the people over here. All right. There you go.
I give it a bit. So the actual, yeah, I mean, like the thing that's working is the left side where you can see the like heat map of like all the depth coordinates that it's getting. The right one, it's using like media pipes like pose detector AI, which only works with RGB. Yeah, there's faster ones, but media pipe it works on like CPU devices, and it was like specifically built for Android phones. Out of the box, it doesn't do multiple poses or like multiple people. So that's kind of what my thing does, where like it does multiple people and just kind of uses like the depth align coordinates. And then for like the actual SDK, that's like all C++, but they have their one Python like wrapper library built in. So I spent like 2 weeks trying to get it so that I could actually like build out the Python libraries because like you can't get it from PIP. So like it's just not online. So like you have to actually download the SDK and then build it locally.
And on this camera, does it run like does it have a processor on board the camera, or not like the OD, or is it?
I think
AI processor.
I don't think it's an AI processor.
You upload models. The RealSense doesn't have that. It's just data. It just gives you back. It's a sensor.
Yeah.
Sensor only.
It's that exactly. So this is just kind of like something that just works with point cloud.
So
like
you had to code all this or use libraries that are running on the PC.
yeah, and I'm this project I mashed 3 APIs together, which was this one's the media pipes API, and then OpenCV on top of that, and then YOLO. So
Media pipe is the part that does
the pose detection, where like it also like looks at like physics like Kalman stuff and like so it's like I think that's why they're able to get it so fast, because like it doesn't just look at like a frame in like a single context. From what I understand, it also looks at like the physics of like where the skeletal like model might be like falling, so it's a bit more of like a state space type of thing.
Oh, so it does more. It's a lot different than OpenCV then.
Yeah, OpenCV. Exactly. I mostly just using OpenCV for the pretty graphics and like the windows.
Yeah, and it's doing skeleton tracking. It's inferring the location of the hand. So
Oh, yeah.
actually, it's not even a thing. You got hands and head marker. So
Oh, that's only what I asked for it, because it does the entire thing.
Oh, okay.
And normally it pulls up like the window, and I'm not sure why that window isn't pulling up right now. but there should be like a little mini window where like it also like visually puts the skeleton on top, which is also why this thing's running at like 3 frames per second. But remember, this is one thread and on a CPU. So like, I think it's like kind of decent for like how much is going on in it. So, yeah, and then like what I want to kind of get to where like I start building out like the bridges and stuff, like I want to be able to like take the multiple people and either put them into like a Blender simulation or have like a Blender simulation that like streams it directly to a robot. And this is kind of like the middle. This is just me writing my own like middleware. So yeah, that's this project.
Thank you.
Hey, next up is Steve.
Hey there. So this is my little blue robot. Called it Blue Ralphie.
All right, give me 1 second. Jordan, if you could stop, or actually.
Yeah,
maybe I can do it right here. There we go. Step 1, and then spotlight the show and tell cam, and yeah, remember, sorry, getting a little slow in my old age. All right, there we go.
Yeah, this is my robot. I affectionately call it Blue Ralphie. Ralph is but it's based on a easy robotics platform. Easy robotics platform. That's what Thomas uses. Gutting robot. So basically, yes. To measure distance to electrical. On top of the robot, we have a servo with skins that vacuum for it. And that come up. The objects is and then ultrasounds here. Arm itself. Arm is the arm is really good. It uses serial chain servos. And they work quite well. It's powered by 1860 batteries. And I drive it around usually with a just a little Xbox controller. Now, currently, I need 2 remote controls, one for the arm and one for the base. Yeah, the next month when I come in, I'll have the LiDAR. Yes. The software I use is this software called Symbium. And so it's a bunch of libraries. It makes it very easy to stitch all the hardware together.
Does Thomas know about this project? You and he have a lot to talk about. He's a big fan of Symbium and
Easy robot.
Easy robot. And then for years and years.
So where are you going to stick the LiDAR?
Yeah, that's what
I'm gonna lift.
Yeah, I'm going to lift the arm up about 4 inches.
Okay, it's gonna be on its own level then.
Yep. That LiDAR will be blocked. I'll have 1, 2.
But that's okay, no, mine is blocked. Pillars don't kill it.
Let's call those dead zones.
Yeah.
They get ignored anyway.
Yeah. Unlike ROS.
It's a pain for a lot of people.
I don't know what you're talking about.
I use Arch Linux, by the way.
Mr. T, thank you.
Very nice.
That's
All right, last on the list is Ethan.
All right, so this year, we've started, something called the OC Makers Foundation. And we have goals to put together some educational components, one of them being around robotics. And so we are slowly starting to put together a mobile platform that is very easy to assemble and 3D print. And then we will build classes around these. So this is just a prototype of the motion system, which is very similar to a lot of the robots that you see around here. It'll do line following, it'll do other stuff, but the key component to this is not only to simplify how hard is it to get into one of these and learn how to program in Python, is to introduce people to how do I do it with a Raspberry Pi Pico. Everybody knows how to do Arduinos. There's a ton of resources out there, like we've seen, but there's a lot less of it in the Raspberry Pi Pico world. And a lot of people don't understand that this is the exact same thing as an Arduino. It's a microcontroller, not a full-on single board computer like the bigger brothers. And so introducing a lot of resources around these and giving them that same capability of how do I do this? Well, you know what? ChatGPT and all that does a very good job of writing Python as well. But how do I do it myself? Let's get some projects out there that have how do I start with this and how do I get this to control this? These robots will will be expanded upon to give you the capabilities of arms like that, do line following, do one of the classes we want to do is a CAD class. How do I extend this to do something else that we haven't designed already? You'll have a section in here where you attach anything you want to this platform and let me help you design it. Let me teach you how to do the CAD around designing this new thing. So one thing that I brought today is I brought two of our motion systems examples. If anybody is interested in trying to put it together, it's very simple. It's not going to really do anything. It's not going to drive around, but it'll just kind of get us started. And then in future months, I will continue to bring these back, probably with more of them, so that we could then do potentially some talks or lessons around, let's make these work. These are kind of our prototypes, so I'm kind of using this group as a little bit of a R&D research a little bit, so that when we take it to a group that wants to learn how to do this but has never touched it before, that we know the struggles are going to run into. How does it go together? And they're all designed to be pieced together very simply. So.
all right. So, Ethan, wait.
Yeah.
Okay. First off, that frame, that's something that you designed in 3D printed?
Yes.
All right. That filament is amazing. What kind of filament is that?
So this is Cookie CAD. I don't even remember the name of it, but it's a dual color. So if you see it on this side, it's kind of bluer, and if you see it on this side, it's a little more
Like
pink.
quantum, like the,
So it's very similar to the quantum. It's a lot of companies are doing that now. And this one has a nice sheen to it.
Oh, it's gorgeous.
Yeah.
That is really.
Gorgeous. And then what are those, tell me about those thingies that you screw into the plastic.
So we're using heat inserts so that they're very easy to go together.
Oh, nice.
And so they melt into the plastic, so they give you a very strong connection, and then it's metal on metal connection for the actual screw. Even though the rest of it's all 3D printed.
Where is that? You talking about the little holes?
Right here.
Oh, okay.
What kind of like tolerance do you need for like when you design the hole to put the like insert?
It depends on the heat insert that you're using. If you use kind of a boron standard, it's about a 4.4 millimeter hole. Will give you an M3 style, but each of the inserts, depending on their thickness and stuff like that, they'll have different thicknesses. I'm sorry, 4.6, not 4.4. The 4.4 is actually a little bit too wide for some of the cheap knockoffs that I have on this one. and if I take these off, you'll kind of see a gap around them. It still melts enough into it where it still gives a decent connection, especially for all it's doing is holding that on. It's not going to put any stress on it. But the idea here, like I said, is, 3D print as much of it as possible so that anybody can get into one of these. And, this is a $1 Omni wheel from Harbor Freight,
Yeah.
right? And this all stems from my animatronic Grogu design. This is the first 2 floors of his design. And so it actually worked out pretty well. And then, so after we've gotten this happy, we'll start introducing more mounting places for like the follow the line, other sensors, and then some joint pieces, which is where we will do the CAD class level stuff. Any other questions?
Yeah, when you say you reheat it, do you like heat it up with a heat gun or something and then attach it? Or is it, what process is it?
So it's a soldering iron.
Soldering iron? Oh,
Yeah, so there's a special tip that you put on them. In fact, I can bring one and we can actually do it here on site if everybody's interested.
So are you saying that you're gonna do talk next month?
I can.
Okay, I mean, we can make that happen.
I'd be happy to do the introduction level. And just take this platform on so that everybody can see it and learn from how this goes together. And again, just following what Ben taught today, is like, how do I get these to drive?
Yeah.
How do I get the arms to move? We have a set of classes that we kind of laid out. One of them is the roaming robot. How do I get around without bumping into things? Or if I do bump into things, how do I know I bumped into it? So we talked about doing things like Hall sensors around the outside so that you could do a touch feel for where is something in space. And then a secondary robot that is more about articulation and picking up things. And then how do they go together? How can I drive around and pick something up? Start stepping through that process. So that everybody can kind of get into this, and then this leads into those more advanced, really cool robots that we see, spot running around outside. How do we get to that? And so these will get you there.
Yeah, out of curiosity, not to put you on the spot, but because Ben was showing us about Visual Studio Code and PlatformIO. As you get into the Pico coding, and I try to sweet talk you into giving a talk on that because it's super awesome. Do you happen to know if that's well supported or supported in the PlatformIO platform?
So VSCode allows you, that's one of its strengths, right? Is that you can do the cross language programming. And so whether you're doing Python or you're doing Arduino C or you're doing C++ or C# or JavaScript or just about anything, you can do it in VSCode. And so that is a strong option for these. We're not 100% sure if we're going to go with Thonny, because Thonny is basically Arduino's equivalent for Python coding on these boards. There's very strongly supported for Raspberry Pi Pico. And so we may go that route because it's very simple and it just takes away a lot of clutter.
Right, so the Python route, Python?
Yeah.
VS Code can do my.
Yes. Yeah. But it just takes away a lot of the complexity of the interface. So it's like, let's just focus on this, do this very simply, and then we'll build it up from there. Yes.
The CAD class, but what software are you using?
So we'll probably use, right now, the plan is to use Fusion 360.
Yeah. All right.
So we will probably stick in that realm. As much as I really want to and love and teach FreeCAD, because it's gone a long way, there's still so many little problems. And so it's like I can't justify in my own heart giving that out to people for their first time.
Yeah, I feel you. I keep dipping my toes in and it is so close, but I haven't taken the leap to try out a full project yet.
Yeah, I've done little things. I've replicated projects I've done in Fusion in FreeCAD.
Okay, you're ahead of me.
But it was painful because just the language by itself is part of the problem, with so much of the software, you're extruding things into space. the word extrudes, we know what that is. FreeCAD doesn't use it. It uses pad. You're padding things into space, and you're making pockets, which are more of a fabrication term than it is a CAD term. So there's a lot of influence from other avenues that get pushed into FreeCAD.
Yeah, I think like, wasn't it like 4 or 5 years ago, there was a Blender reorg where they begrudgingly moved towards more industry standard user interface. I think they're, well, now, the other guys, they lost their funding, so they shut down. So first one will take up the mantle, and they will have their own moment to take them from quirky UI to a viable alternative.
Yeah, it's a lot better than it was, and you can select what type of interface you're used to. I mean, Fusion's not one of them, but there are close examples in FreeCAD now that you can, but so that's what I'm doing today. Like I said, after all this is over, if anybody wants to come try putting one of these together, please do. And they're here. So.
Cool, thank you.
Excellent. Right, thank you.
So if anybody wants to, put one, Ethan's back there on the back. And by the way, I don't know if you guys know Ethan, he is, the organizer of the Orange County Maker Fair. So he's, been one of our good friends, since we started, coming to the, the Orange County Maker Fair. And now we do collaborations with them. So thank you, Ethan. That was the last on the list.
I've forgotten something to say about the price and stuff, if we have time.
Yeah.
Just a couple things if we have time. So on that robot I was talking about, the Micro Maqueen, now the new version is this one, V2. These are a little pricey, but you get a lot in this thing that could keep you busy for a long time. There's like, I showed you, or I could show you a list of 20 different lessons that will take you all the way from beginner into advanced, to a few into the advanced. So that's 50, but that's not the whole thing is going to cost 70 because you need the micro bit itself is the board. So that's about $19, $20, call it 20 and 50 and $70. But to me, that's, it's a good investment for it, because then you don't have to worry about the hardware. The hardware is going to work very well for you. And you'll learn the software. You can also buy, like I bought this thing here, well, there's also kits that come with multiple things that you can get, but I bought the loader separately, which is that little shovel, which that was not that expensive. But there's a bunch of add-ons you can get. The other thing I wanted to mention briefly is that I happened to separately had bought what's called the Husky lens, and it's this cool little device. Let me share my turn on video again. Let's hit the share button when I want to hit stop. Stop should be on the left. So this little device here, you can see my, okay, thanks. See my face there. This is the Husky lens. This is what the front looks like. Not much lighting. This device can do a lot of AI stuff. And so it can do line tracking, for instance. So there's a mount that you can, since these are both the same company, DFRobot, or at least they sell both. The Husky lens will attach to the robot where instead of the sonar, and it points down normally the way they have it, and it can do line following. So, and in fact, what's really cool, this stuff is just built into into this device. So, well, let me first show you since my beautiful visage is on the screen, not, but it does facial recognition. So you can see it's got my face there. It says face. Well, yes, it can suffice as a face, that's for sure. But it can also do, yeah, object tracking, line track. What's cool is this line tracker. Now, if this is pointed down to
Friend.
well, except I have to do it on this. It has to be over here because the people have to see the. So yeah, you see that line. Oops.
Oh, it's kind of lighting it.
Yeah, well, go to the other side. This one's better. And then, where are we?
Just tilt the camera.
Oh. It's hard to.
You have to rotate it so it's not looking at your face.
There.
Yeah. I see a little.
It got it for a while there, yeah. You see, it sometimes it gets it.
You know, this is
Oh,
the,
there it is.
yeah, so there it is. Yeah, so I mean, when this is mounted, it'll work better, obviously, I mean, according to them. And, yeah, according to the demoers, but this thing can do, this itself is a really useful tool. Object tracking, object recognition, and you can program it immediately by pressing a button. So, I guess this is another demo of a different product, but this goes with your robot and can be used. But you can recognize different colors. I think does it remember this now? Yeah. I just hit the button there to memorize this green color. And or we can do it again. The pain to do this type of demo. Well, it worked today. It worked at home. Well, it's just hard work. What you can do is you can memorize a color. Color recognition. So I press this button, learning. Okay, so now it's going to remember one of these colors here. Maybe the lighting's different now. It is a problem with color recognition.
You know, all those things you have to, if you turn the camera around, you're getting a different brightness of light.
There,
Oh,
there
there you go.
There you go.
Hey.
Yeah, but in a more, not a situation that's at least got a little control, then it'll work reasonably well. If you keep the lighting similar and all that. So anyway, thanks. Yeah, that Husky Lens is another add-on, and one other thing is, it's a good example of in the make code system here. So another extension you can add is the Husky Lens. I haven't even done it yet, but I saw it. So you can type this and then Husky Lens, or there it is, Husky Lens. And there's my robot. So you add this, and now the Husky Lens is there. So now when I do connect the Husky Lens, I'm not sure how I hook. Oh, I guess you probably need you'll need a little cable to connect the Husky Lens to this robot, because the robot does have a bunch of pinouts. But now, once you've done that, you can now fold in Husky Lens stuff to follow the line into your code. And there's an example chapter in here to use the Husky lens to follow a line instead of the line following, or instead of the infrared sensors. So yeah, in fact, I think it's down here, but yeah, and it shows you, yeah, here's the Maqueen functions, for instance, and then the Husky lens AI camera block stuff, and then yeah, if you look in, I guess, in the chapters here, there's line follower, right, blah, blah, blah. And then here, project 7, 8, 9 are Husky lens line tracking. And, oh, and it does tell you, I think here it tells you how to hook it up. So this is what it looks like. The thing I just showed you mounts with this bracket that comes with the Husky lens. And the camera recognizes black line, and Maqueen drives along the road, download program, etc. And so, yeah, then you have your, so yeah, that's I just wanted to add, and the price and everything. So you're getting a lot. The Husky lens, I think it's like $50 or something, but I'm not.
I got it right here, it's 55.
55, yeah. So it's another 55. So that's like another thing you can advance to. Once you've done all the stuff with that before that. And of course you could upgrade to using the loader or other add-on mechanicals they have.
So I see it has a little servo. Does the loader like go up, or what does it do?
Yeah, this loader goes up. It goes up and down on the servo. I haven't. I just, the one code I have is it just moves it to a default position, so it's not interesting right now. But I have. I was planning. I'm planning to use this to pick up something, and maybe put in the Husky lens to detect the object, and then go like little ball on the ground, and then use the shovel to catch the ball, or something easy enough that you can scoop it up, that it will stay in there. And now that I know, I had these on my shelf. I didn't even know that this robot could take the Husky lens immediately, and then there's all the support for it in the code and everything. So you don't have to so it's convenient for me, for anybody, for beginner to advanced, when all those functions are ready at your fingertips in an IDE like that. You can just start programming without going through more arduous tasks of reading the whole manual for this thing and figuring out how to upgrade its firmware and do all this detailed stuff. You've got this make code that's got the commands available right at your fingertips. And so sometimes you may need to go deeper than that, but in a lot of cases, you can do great kind of demo examples with just what's available, because and what they give you. So yeah, thank you. That's so. All right.
There's a question and comment. I'm reading the specs here, and two of the useful features that it doesn't seem to have is the ability to download the raw data, which is 320 by 240. And the other thing that it doesn't seem to allow you to do is upload new firmware or new software. It's got AI chip on board, and you talk to it through an I2C interface.
Yes.
And you can only call its built-in functions, and it's not upgradable.
Yeah, that's the limitation. That sounds familiar, because we all bought, a lot of us bought this a few years ago and didn't integrate it into our more advanced robot, maybe for that reason. But for these simple cases, it could be quite, it is for like a beginner. This already does so much. It identifies colors, people, objects, tracking.
Yeah, it's a hardwired inference.
Yeah,
It's basically.
hardwired. So for people that don't need to customize anything and can just use the serial output of this, you're good to go, right? And it does a lot of functionality in there. And I can't claim I've done a lot with. I haven't done much with it, but just the ability to click here and recognize that's a cup, and then try and do things that are very easy physically to just press buttons and get it to start working, then it's a big acceleration to get something done. You know, simple, you know, relatively simple, but using advanced AI camera stuff. So it's not simple inside there, but it's simple to you. Right? If I don't find this yellow color in.
Thanks, Jim. And that was all of the show and tell that we had. And unless anybody else has another one, we are on just free time.